GCSE Physics boosters, calculating energy. We're talking about, in this video, kinetic energy, elastic potential energy and gravitational potential energy, and a little bit of practice using the equations to work out these different types of energy. So here we go. Now, kinetic energy, if something's moving, then it has kinetic energy. And we can calculate its kinetic energy using this equation, and you need to remember this equation. You have to learn this equation and a few others as well. So EK is a half mv squared. So EK, kinetic energy in joules, capital J, joules, is a half, which is 0.5. M is the mass of the object in kilograms, and V is the speed of the object in meters per second. So it's V squared. So it's a half times M times V squared, the speed squared. Let's have a look at a couple of examples. There's a little doggy having a run and a car. In fact, what I'll do is I'll show you my answers in 3, 2, 1. There you go. So the first one, kinetic energy is a half mv squared, so 0.5 times 12 times 7 squared is 294 joules. And the second one, a half mv squared, you should get 320,000 joules or 320 kilojoules. If you do 320,000, put a comma, you know, for 1,000, and it makes it a lot easier to read, and you're much less likely to make a mistake about how many zeros you write down. And note, you write down the equation, bung in the numbers, substitute the numbers in, work it out, don't forget the units. I say this to my students again and again and again. Some of them listen to me. Write down the equation, bung in the numbers, work it out, don't forget the units. When an elastic object, like a spring, is stretched or compressed, it stores elastic potential energy. The word potential actually means stored, elastic potential energy. And the equation there is that E for energy, E little e, is a half k E squared. So E, big E, is the elastic potential energy, again in joules, equals a half, or 0.5, times K. K is the stiffness of the object in newtons per meter. For example, it might be the spring constant in newtons per meter, the stiffness of the object, and little e is the extension, and that's in meters. I can imagine you might be given that in centimeters, so be careful. It's got to be in meters in this equation. If you want your answer in joules, that has to be in meters. So a half k E squared. Again, here's a couple of examples. I suggest you pause the video and have a go at them yourself. Remember, write down the equation, bung in the numbers, work it out, don't forget the units. And the answers are 3, 2, 1. There you go. Okay. One thing to point out here, my answer for the first one, 0.625 joules. At A level, I would expect my students to change that to 0.63 because 2 sig figs is adequate. 0.625 is okay. 0.63 would actually be better. Next, now gravitational potential energy. If the height of an object gets bigger, if you lift something up, then it gains gravitational potential energy. If an object falls or goes down, then it loses gravitational potential energy. So an object will either gain or lose gravitational potential energy. We don't say how much GPE it has. We calculate how much it gains or how much it loses. And to do that, we use this equation, which is EP, the gravitational potential energy in joules, equals mgh. M is the mass in kilograms. Little g is the strength of the gravitational field. Gravitational field strength, if you're on Earth, then it'll be 10 newtons per kilogram. Okay, at A level we use 9.81, but GCSE 10 newtons per kilogram. You'll be given that actually. And then h is the change in height. Whether it's lifted up or whether it falls down, h is the change in height. This is another equation which you need to remember. Make sure you know which equations you need to remember. It'd be a jolly good idea to write a list of them, stick it on your bedroom wall and learn them. Here's a couple of examples. Again, I'm going to show you my answers in 3, 2, 1, and there you go. Write down the equation, substitute in the numbers, the data that you're given, work it out, don't forget the units. Now, one thing that you will have to do on the higher paper is possibly rearrange equations. Now, if you're okay at maths and if you're doing the higher paper for physics, then this shouldn't be a problem for you. If you know that EK is a half mv squared, then what does m equal? Or what does v equal? Can you rearrange this equation to give an expression for m, to give an expression for v? You should be able to do that. Well, here's your chance to prove it. Have a go at this. A tennis ball of mass 0.06 kilograms has 27 joules of kinetic energy. Calculate its speed. So I'm going to show you my answer. Have a go yourself. I'm going to show you my answer in 3, 2, 1. There you go. So write down the equation. EK is a half mv squared. Rearrange it so v equals the square root of 2ek over m. Then bung in your numbers, substitute the data in there, then work it out, and you should get 30 meters per second. Always rearrange the equation before you substitute the numbers in. Okay, don't be bunging in numbers and then trying to rearrange it. You'll get totally muddled up. Rearrange the equation, then bung the numbers in, then work it out. Here's a bit of a summary of this video. There are lots of marks in the exam for doing calculations. So practice, practice, practice. If you've been told practice makes perfect, you've been told rubbish, it doesn't. Practice makes progress. You will get better and better. The more you practice, you will progress. Get hold of a revision guide. Look on BBC Bite Size. As many worksheets and things your teacher has given you. Practice, practice, practice. When you do one of these sums, write down the equation, substitute the values you're given, write down the answer, don't forget the units. You might have to rearrange the equation, especially on the higher paper. You probably have to do this at least once. And remember, don't substitute the data in until after you've rearranged it. There are some equations that you need to learn. For example, the kinetic energy one and the gravitational potential energy one, you need to learn them. And lastly, write neatly. If the examiner can't read it, if they can't make sense of it, then you won't get the marks. So write neatly.